Now, in our last video, let's see how we can test this code. And again, I put my data from the textbook in this data package. Now, to get the address, you can go on the right click on the element, click properties, and here it's your entire path. That's what you will need to use for your computer, depending where you put your data. Don't use my path because it will not work. And here it's an example of a small graph. It has 13 vertices, 13 edges, and for instance has an edge from vertex 0 to vertex 5, from between vertex 4 and 3, between vertex 0 and 1, and so on. So what we'll do in our test will be to declare a file with a location of that file, and again this will be different for you. Then I create a graph by reading the graph from this file, and then I print the graph using the toString method that we discussed. And I do this for all these three graphs. Tiny, it's a small one, 13 vertices, 30 edges. Now medium, it's a more representative one, has 250 vertices and 1200 edges, so it's really becoming a more significant graph. Large is a huge graph, so you see how long it takes to open it, and has 1 million vertices and 7.5 million edges, which is a lot. So this one, you can imagine, it will take a long time to load, process, to do all the operations. You see it's not even opening here right now, but hopefully it will not block my Eclipse. That's how big it is. Okay, seems like it blocked my Eclipse. Let's see if I can. Yeah, it's a too big of a file, even for Eclipse to handle. So don't try to open it. Okay. Okay, so some error. Let's restart. You can open it on web. Hopefully it didn't destroy my file. I don't know, I'll need to recopy it just to be sure. So let me check my file first. So let's copy this one. I'll copy and put it back here just to be sure that I don't. Yeah, many things change. Okay, so what I would like to do will be to replace this file here. Doesn't allow me. Let's delete it. Okay, and I want to paste. Okay, now I have the good file back. So don't try to delete. If you delete, put it back here. You can download them from the web and then copies in this package of data. Now let's run our program and see what we'll get. And as you can see, I got the tiny graph very fast and has the vertices from 0 to 12, so 13 vertices, and then it's showing all the edges. And sure, it will show first the edges starting from vertex 0 because this is our adjacency list is, and we can see it's linked with vertices 1 to 5 and 6. Then we'll have the links from vertex 3, which is linked with 4 and 5, with vertex 4, which is linked with 5 and 6, 7, which is linked with 8, 9 is linked with 10, 11, and 12, and 11 with 12. Now, sure, 0 is linked with 5, 5 will be linked with 0, but it's the same edge. So here I don't show the adjacency list, here I show all the edges as pairs. So that's why it's different from the adjacency list. Then the medium graph is 250 nodes. You can see how many nodes, for instance, are linked with 0, several of them, and so on. So this is a much more complex graph to process. Now, the large graph, we have this message, which means we succeeded to read, so it's loaded, but to print it, it will take a long time to print because you need to generate this, and it's for 8.5 millions of edges. And moreover, then to print on the screen so much data, it's taking a lot of time. So you will need to wait, and then you'll see the screen scrolling like crazy, printing that huge string that was generated with your graph. We'll not wait for that, but and you don't need to wait for that. You can put as a proof of your running just a screenshot with your tiny and medium graph. The large graph is not needed, but I wanted to show it to you because we may use it later for various operations. Okay. Now, this concludes our test, and based on these graphs, we'll be ready to do the next operation in which we want to compute the links of the various ways to process the graphs. And first, we'll discuss two ways to traverse the graph.